Hello, guys. Dave Bernier here. So now we are talking about the second agentic design patterns, which is routing. Some people might refer to it as being a classifier. So the idea here is that you have an agent that analyzes the request, the inputs, but not necessarily word by words, but it has to analyze the intent behind it. And from its understanding of the intent, it decides to send the request to a relevant or a specialized agent, route, flows, or any other destination that is more relevant to it. If we just have a look here at the implementation, is that um, we receive a request from a user, the LLM will determine the user intent and will return it. And based on the intent and the use case that the agent can manage, it will route it to a specific route. Here, that could be another agent, that could be a deterministic flow, that could be a tool, that could be anything that you need it to be. But the point here is that each branch has its own specialization or its own specificity. And it's always good to have an unclear branch or output to bring it back to the LLM and maybe ask again to the user to clarify it. Um, so the pros of this pattern is that it allows flexibility in understanding some human requests, because as human, we're not always clear in what we want. So this allows the agent to either clarify it or to understand underneath the meaning of the person and try to understand what the person actually wants. So it's quite useful, let's say, in customer support. So if a customer or a client writes an email or writes in the chat can find and understand what the user or the client wants and redirect it to either the right department, the right agent, or call the right database to get some informations, yada, yada, yada. Some other pros is that it can increase the reliability of your system, because now you have different branches that are very specialized. So it's not a single LLM or a single tool that has to cover everything. You can split it into specialized branch and flows, and this way you can have some increased reliability. In the same fashion, it allows for some modularity and separation of concerns. So that way, if you know that a flow is not working, or that the what the agent returns is not ideal in these specific cases, well, you do know in which part of your infrastructure or in your architecture to go and dig more, because it's very, very well, the separation of concerns is well done, and that way you can go and look at the single things that has more chance to be the culprit of what's not working. Then it's a lot more scalable, because you don't have to rewrite the whole thing if you need to add a use case. You can just simply add a branch, adapt the detection or the routing logic, and you don't have to rewrite or to affect or to impact any other branches that existed before. Same with the traceability and control, kind of in link with the separation of concerns and modularity. That way you can have some logs, some traces of every single branches of the request, understand if it was the right branches. If something broke, you can see more clearly where the things broke. Uh, on the downside, there's not a lot. I'd say, again, the latency. As soon as you add a part in your architecture, you introduce some latency, because the LLM, in our case, will have to analyze and understand. You can have an increased complexity also, because the more the system scales, the bigger it becomes. So the modularity is a good thing, but when it gets very, very big, it adds some complexity to it. So here, the prompt itself is quite simple. So analyze the user's request and determine which handler should process it. So a handler would be one, there would be one handler per branch. So if the user is asking about the weather, you output weather. And for some different use case, so we have weather, news, stock market, and unclear. Important, and we have to specify it, only output one word, the name of the specialist or of the handler. The possible values are weather, news, stock market, and unclear. So from there, we do receive a single word, and we have a switch case. So for every possible output, we send it to the right branch. In our case here, we don't need to actually call any weather service or anything. The idea is to focus on the routing aspect of the pattern. All right, so here, if I start the chat, so how much is Apple today? It should be stock market. So categorized as stock market. Good. What was the temperature in Quebec? This should be weather. Awesome. Was Apple the highest brand this last quarter? So this could be news or stock market. I'm curious to see what it will return. It went to stock market. How is the situation in Ukraine? This should be news. That's it. So how is the temperature in Apple? Let's try to mess it up a bit. How is the temperature in Apple for the next quarter? I guess it's that. Oh, unclear. This was not clear. Please clarify. Awesome. So here you get the gist of it. So, and you see I did some big typos. I was not clear on some stuff, and because it is an LLM, it was able to kind of understand what I meant, or try to understand what I meant. Here, it doesn't necessarily have to be an LLM. This is what we used in this case, but it could be a vector database. So you can have and go in to look into a database to find some semantically close subjects or content, and from there get it back in the flow and route to a specific thing. It could be some machine learning model based, where you do have, let's say, a discriminator like a classifier, and from there you can determine which route to take. So that's pretty much it for the routing design pattern.